Hello and welcome to another video. In this video we're going to be working on minimum deletions to make string balanced. And in this one you're given a string consisting of A's and B's. And you can delete any number of characters in S to make S balanced. So S is balanced if there's no pair of indices such that I is less than J and SI. So basically what they mean here is you need to have a string where all A's come before all B's. So in this case, you can, in this first example, you can delete these two A's and that would happen. That's one of the things you can do. Or you can do something else, I think. Yeah, so you can delete this B and then this, actually, no, you would delete, yeah, you delete these two A's for one of them. And then, actually, I think this is the only one. Let's see. So you can delete these two. Oh no, okay, so you can delete these two or you can delete like this. Yeah, there we go. And then you'd have A's followed by B's. Either one's fine. And then the second one, you have to delete the first two characters. So basically, and the string is 10 to the 5th. So basically, let's take a look at like some things that can happen to a string. So let's just say we have a string full of A's and B's. Yeah. So let's say we have like this first example actually. So maybe make it a little longer. A, B, let's say. Okay. So one solution we can have is just turn everything into A's or B's, or just delete all A's or all B's, right? So we can just count up the number of A's, count up the number of B's, and delete one of them. And then if that was a solution, delete one of them, you'd want to delete the one that there's less of because that would be better, right? So for A's, we have 1, 2, 3, 4, 5, and then for B's, we have 1, 2, 3, 4, 5. So it's a tie. So you can delete all your A's or all the B's, and that would be one thing, but that wouldn't be the best necessarily. Now, if you don't do that, then you're gonna have a string with A's and B's. So if you have a string with A's and B's, what's like the best way to pick a string, or what's the best character to pick in a string to know exactly what everything else needs to be? Well, because a string needs to have a bunch of A's followed by a bunch of B's, if we either pick the last A in the string or the first B in the string, like let's say we want to make a string where it's the first B location is here. That means we know that all of these would have to be an A and all of these would have to be a B. And we can figure that out if we have counts here, right? So if we know how many A's are here, how many B's are here, how many A's are here, how many B's are here, we know how much it takes to turn it all into basically this, right? We basically have to delete all the A's here, and then we'd have to delete all the B's to the left, and this would be our string. So that's what we're going to kind of do. So we're going to say the location we're looking at is location of first B in the string. And for any result string, like one of these locations has to be the location of the first B, right? It can be like here, 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 here. So we're basically just going to traverse a string and we're just going to say like, if this is the first location of a B, how many deletions do we need? If this is the first, how many do we need? And so the brute force here would be, you pick here, like let's say this is the first location of a B, and you check how many A's do I have on the right, how many B's do I have on the right. Then same thing here, how many A's, how many B's. Then here, how many A's, how many B's, how many A's, how many B's. That'd be n squared. But notice when we go from here to here, all we're doing is, so we're gonna have 4 variables. We're gonna have left A's, left B's, and then right A's and right B's. So right A's will be 0 and right B's will be 0. So like in this case, like for our whole string, we're just gonna say this is all zeros. And then as we get to something, now that goes away from the left, right? It's no longer on the left, it's the current one. So here we have 1 less left B. So we have 4 left B's and we have 5 left A's. And we have 0 and 0. So if this is the first B, that means we have to delete all of this, there's nothing here. And then we have to delete every B to the left. So we're gonna have to delete all 4 of these B's. So that would cost us 4. That would be an operation that would cost 4. Then, before going to the next one, now this B that was deleted needs to go to the right. So now the right B will have 1. Then we come over here and same thing. Now this A is no longer in the left, so we're going to delete it from the left. And we're going to say, okay, if this is the first B, well, this can't be the first B, right? Because this is an A. So because this is an A, we can just skip it. Because we can't convert a character. It turns out it doesn't really matter. Basically, it's never going to be best to convert an A into a B. It's never going to be, it's going to be like tied for best. But yeah, so if it's an A, we can just skip the character, but we still have to do the like addition. So if it's an A, we're just going to say, okay, let's just move it to the right and let's skip, because we can't, this can't be the location of the first B. It's not possible. So then we can go here. So we delete this from the left and say, okay, if this is the first B, then how many operations will we need here? So our best is 4 so far, I think. So here, if this is the first B, then all of these need to be B's, so we need to delete every A. So every A on the right is 1. And then we need to delete every B on the left, which is 3. So we need to delete 4, so that's 4 again. Then we take this B and we put on the right. Then we delete this A from the left, put on the right. We don't need to do anything here because it's an A, so we can just skip. Okay, delete this B from the left. Okay, now if this is the first B, we need to delete every A from the right, which is 2, and every B from the left, which is 2. So that's 4 again. And then we need to put it on the right. Then we delete from the left. And same thing, it's going to be the right B's, or the right A's, plus. So you actually don't even need to keep track, if you think about it. You don't even need to keep track of, all you need to keep track of basically is the A's on the left and the B's on the right. No, other way around. You need to keep track of the B's on the left and the A's on the right. Yeah. So you could just get rid of some of these variables if you want to. In fact, we can do that. But regardless. So you basically just keep doing this. And then this is how you get your solution. So here, yeah, so we're going to need to get rid of every B on the left, which is 1. And then every A on the right, which is 2. So this is the best so far, so this is 3 total. And then we add this to the right. Yeah. So now we have 4 B's on the right. And then we get rid of this A from the left, add it to the right. Get rid of this B from the left. And if this is the first B, then we need to get rid of all the A's on the right. So that would be 3, and then all the B's on the left, which is none, so that's 3. So our best so far is 3. Then we need to add this B to the right, so 5. And then you can't do any of these, so you're basically done. So your best is 3. And that is the case, right? And that was this case. Like if you just say this is your string. Sorry, you don't convert, you just delete, right? So it would basically be delete, delete, delete. There we go. Okay, so all we really have to keep track of is the number of, we can just have 2 variables instead of 4 to keep it simple. So we need the number of B's on the left and the number of A's on the right. So that's what we'll do. And then this is how many changes we need for the given index. And we can just modify this as we go, and then we can just read this right to left. Okay. So let's do that. So let's just only have these 2 variables, B's on the left, A's on the right, to make it less. Okay, so we'll have left B's, and we'll have right A. Okay, so as we go through this string, we need to count up the number of left B's, which are just every B so far. So we'll just say for, yeah, so this will be like I equals 0. If s at I equals b, left b plus plus. Okay. Now we're going to traverse the string backwards, and we're going to count up all these things. And our initial result will be the minimum of turning everything into an A and turning everything into a B. So turning everything into an A will be getting rid of all the A's or all the B's. So getting rid of all the B's will be left B, and getting rid of all the A's will be s length minus left B, right? So the number of A's is the length of the string minus B. Okay, now we're going to traverse the string backwards. So as dot length is 1, I is greater than 0. Okay. So what we want to do is, if the character is an A, we want to, actually no, if the character is a B, we want to subtract it from left B's. So we can just do left B minus equals s dot char at I equals, I think you can do a char comparison like this. So if it's a B, we will subtract 1, and if not, we will subtract 0. Okay. Now we can say a result equals mathmin of the old result. So remember, the changes we need to make is, if this is our leftmost B, then every leftmost B needs to be deleted, and every rightmost A needs to be deleted. Then, before we go to the next character, now this character will be on the right, so we need to basically do the same kind of thing. Right A plus equals, so if it's an A, add, if not, and I think these are lowercase. Okay, and just return result. Okay, and I think that's all we need. So we use just the two things we needed, the left B's and the right A's. All right. And we got a -2. Interesting. Okay, so let's just double check. So if it's a B, oh, we need uppercase B or lowercase b. Okay, hopefully that's good now. Yeah, okay. Yeah, I think there are some solutions. You can even simplify it a little bit past this, like you do like a 1-pass or something. But basically this is so efficient that like all these runtimes are just something that's like a little bit simpler code, but the runtime is exactly the same. So yeah, just some other shorter thing or something. I don't know. Yeah. But that doesn't really matter. So like for problems that you're basically not using you're not using a lot of variables and it's linear time, I wouldn't be concerned with like what % you get here, because it's all going to be like, if you use like 1 or 2 less variables, you're going to get better runtime, and all that stuff is irrelevant. Like the ones you care about are the ones that are actually like difficult runtimes, and there's like actually big changes you can make, but you can't make anything faster than this. You might be able to like do 1 loop instead of 2 or something, or yeah, which is not a big deal. Okay, so time-wise linear space O1. Yeah, so hopefully this is helpful, and yeah, for these problems I would encourage you to, because I didn't even notice this until I drew this out now, that I only need the left A's and the left B's. When I earlier did this, I kept track of every variable, but you don't need every variable. So just some things to think about. Drawing it out definitely will help you catch your mistakes. And then you can even like draw out this thing, look at your code, and then figure out like, okay, what's going to happen exactly, make sure you didn't miss anything. And yeah, hopefully that was helpful. If it was, please like the video and subscribe to the channel, and I'll see you in the next one. Thanks for watching.